Hello students, welcome to my channel. Today we'll be discussing about rational numbers. So before we start to discuss about rational numbers, shall we recall what we know from before? So we know that there is something called as natural numbers, right? So what are natural numbers? So numbers that begin from 1, 2, 3, 4 and goes so on are called natural numbers, right? So then what are whole numbers? So whole numbers begin from 0. So and then there is 1, 2, 3, 4 and so on. So if I put a number line like this, where I begin with 0, 1, 2, 3, 4 and so on. So in this number line we have begin the numbers from 0 extending from 0 to 1, 2, 3, and so on. So, are there any numbers before 0? Do you know any numbers before 0? So, to answer this, we need to know integers. So, the numbers before 0 can be represented as, if I put 0 here, 1, 2, and so on. The numbers before 0 can be represented as -1, -2, -3, and so on. So, these are negative numbers. Say, for example, you live in a building with 8 floors, okay? There is a building with 8 floors and there is a basement floor where all your vehicles are parked. This is a parking area. Okay, basement area is the parking area. So when you enter the lift, so in the lift there is 1, 2, 3, 4, 5, 6, 7, 8. Correct? Then there is 0 for ground floor and for basement there is -1. So if I say ground floor as 0, this is where it begins. All the floors which are above 0 will be 1, 2, 3, 3, 4 and so on. And the basement floor which is below the ground floor. Correct? Basement floor is below the ground floor. So it will be represented as -1. So integers are numbers which can be positive, negative. So all the positive integers are beyond 0. So they are called positive integers. All the numbers which is below 0 are negative integers. Okay. So this is clear. So we know now what are natural numbers, whole numbers and integers. Integers are usually represented by symbol Z. Okay. Next we have rational numbers. Okay, what was the need for introducing rational numbers? So if you see the number line, now we have got negative integers, 0, positive integers, and so on, right? So does there exist any number between 0 to 1? Have you ever thought there exists any number between -1 to -2? So all these numbers can be represented in the form of P by Q. That is a fraction. Correct? So rational number. Rational number is a number which can be written in the form of P by Q, where both P and Q are integers and Q is not equal to 0. So this is a rational number. Okay. So till now everything is clear. Okay. So now we shall study the properties. Properties of these numbers. So the first and foremost we will discuss about closure. I will explain closure property with an example. So I'll take now the example of whole number. We will first discuss about whole number. Okay. So I will tell now closure property for addition. So if A is a whole number plus B is also a whole number equal to C. The sum of A plus B is C, whether it is a whole number. So now we have to check. Okay, suppose whole number, right? So we'll take an example, random example of a whole number. 3. 3 is a whole number plus 0 is a whole number. The sum of 3 plus 0 is 3, is also a whole number. So what can we say now? Whole numbers are closed for addition. Okay, so we will check for subtraction now. For subtraction, if A is a whole number, minus B is also a whole number, whether C is whole number or not. So I'll say that 3 minus 5. Okay, 3 is a whole number, 5 is a whole number. 3 minus 5 is minus 2. Now this is a integer, not a whole number. So this property is not closed under subtraction. So this is clear. So now we'll check for multiplication. Okay, A into B. If A is a whole number and B is a whole number, the product of A and B is C, whether this is a whole number or not. So 2 into 0 is equal to 0. 0 is a whole number. So 2 is a whole number, 0 is a whole number. The product of 2 and 0 is 0. So it is also a whole number. So we can say that whole numbers are closed under multiplication. Is it clear? Okay. We will check now for division. Okay. If A is a whole number divided by B is also a whole number, A divided by is equal to C, whether this is a whole number. So 4 is a whole number divided by 0 is a whole number. Any number divided by 0 is not defined. So this property is not closed under division. So simple. So we can say that by closure property, we can say that for whole numbers, are closed under addition and multiplication, and not closed under subtraction and division. Simple, understood? So this is how you check the closure property. So we talked about whole numbers, the closure property for whole numbers. So what about natural numbers? So now this is your homework. Now you will have to check and let me know whether closure property holds good for all the natural numbers. Okay? Okay. Chalo. Next, we will talk about integers. Okay. For integers, first we will check for addition. Okay. A plus B is equal to C. So I'll take an example of minus 2 plus 0. Minus 2 plus 0 is minus 2. Minus 2 is an integer and 0 is an integer. Why do I say 0 is an integer? So you have seen the number line. So it starts from negative, 0 and positive. So 0 is included. So minus 2 is also a integer. So I can say that it is closed under addition. So A minus B is equal to C, where A is an integer, B is an integer. So minus 4 minus 5. Okay. What is minus 4 minus 5? Minus 4 minus 5 is minus 9. Correct? So minus 4 is a integer, 5 is a integer. So minus 4 minus 5 is minus 9. It's also an integer. So this property is closed under subtraction. Okay. Next we will check it for multiplication. A into B is equal to C, where I'll take 0 as an integer into minus 3 as an integer. So the product is 0, it is also an integer. So this property holds good for multiplication as well. Next, division. A divided by B is equal to C. So we will take 5 divided by 0. Any number divided by 0 is not defined. So this property is not closed under division. So what we got to know? Integers are closed under addition, subtraction, and multiplication. Not closed under division. Okay, clear? Okay. Now we'll check the same closure property for rational numbers. Okay, chalo. So A plus B is equal to C. So this is the first one for addition, where A is a rational number, B is a rational number, and C, whether it is a rational number or not, we have to check. So A is a rational number. So I'll take 1 by 2 plus B is a rational number, 0. 1 by 2 plus 0 is 1 by 2, also a rational number. Correct? So it is closed under addition. Okay. Next, A minus B is equal to C, where A is a rational number, B is a rational number, C, we have to check whether it is a rational number or not. We take 0 minus 2 by 3. 0 minus 2 by 3 is minus 2 by 3. This is also a rational number. So it is closed under subtraction, correct? Okay. Now we'll check for multiplication. A into B is equal to C, where A is a rational number, B is also a rational number. I have to check whether C will also be a rational number. 5 by 7 into 0 is equal to 0, also a rational number. Okay, why do I say 0 is a rational number? 0 can be written as 0 by 1 in the form of P by Q, where P is an integer, Q is an integer, and Q is not equal to 0. So 0 is a rational number. So it is closed under multiplication. Multiplication. Okay. So what about division? A divided by B is equal to C. A is a rational number, B is a rational number, C we have to check. Okay. So I'll take example of minus 7 by 3 divided by 0. Any number divided by 0 is not defined. So it is not closed under division. So summarizing, for rational numbers, the closure property holds good for addition, subtraction, and multiplication. Is not closed under division. Okay, understood? Clear? Okay.